Your reactants produce your products. We have a chemical reaction that is taking place. Remember, in a chemical reaction, a new substance is formed. A new substance is always formed in a chemical reaction when a chemical reaction occurs. So the law of conservation of mass states that matter can neither be created or destroyed. It can only be rearranged to form a new substance. Look at here. We had carbon dioxide. We had water. We rearranged what we had up top. And in the end, we got sugar and we got oxygen. All right, so doesn't that make sense? Matter can't be created or destroyed. We didn't create anything new from over here on this side. All we did was changed up. We still have the same number of elements. The exact same elements. We have carbon, oxygen, and hydrogen. Over here we have carbon, hydrogen, and oxygen. So we still have the same elements. We still have the same number of those elements, which I'll show you in a few minutes on either side. All we did was change them up, rearrange them a little bit, and formed a new substance, sugar and oxygen. All right, so to take that a step further, we need to know what a subscript is. A subscript is the small number behind the elements. The 2, the 6, the 12, the 6, and the 2 here. These little bitty numbers, the smaller numbers that are behind an element, tell you exactly how many atoms of that element it is, or that you have. That is your subscript. You can always remember that that smaller number is the subscript because it kind of looks like it's underneath those elements. And think about a subway. It's underneath the ground. Think about a submarine. It's underneath the water. So that small number is known as your subscript. Your coefficient is the big number in front of the molecule. So the 6 is my coefficient here. This 6 is a coefficient. That 6 is a coefficient. They're the big numbers. They also tell you how many molecules of something you have. This tells me we have 6 molecules of carbon. We have 6 molecules of water. All right? We have 6 molecules of oxygen. All right, to take it a step further, we need to know exactly our law of conservation of mass. We said states that matter can't be created or destroyed. It can only be rearranged to form a new substance. We need to find out, does this fit the mode of the law of conservation of mass or matter? Does it? Is anything lost? Is anything gained? Or does it stay the same? If this holds true, if it fits the law, that means we'll have the exact same elements on both sides. We'll have the exact same number of atoms for each element on both sides. Let's test it and see. First thing you need to know is I always like to have my students, if there's an element missing a number, there's no number behind this C, there's no number behind that O, I always have them put 1, which will come in handy later when we're doing our adding. All right, remember that there are 2 separate sections. You have your reactant section and you have your product section. So the first thing we're going to do is calculate our totals in our reactant section. By doing that, we must add the subscripts first. Subscripts are meant to be added together and then multiplied by the coefficient. So we're going to say 1 plus 2 gives us 3. All right, so we have 3 . All right, we have 3 atoms here. We're going to multiply that by your coefficient, which is 6. 6 times 3 equals 18. So that means in this section here, we have a total of 18 atoms. Then we're going to do the same thing for here, because this plus separates these 2. These are reactants. They're together. We'll add them together after we get our calculations. All right, so we're adding these coefficients. 2 plus 1 gives you 3. 3 atoms here. And remember, we have to multiply that subscript by the coefficient. So this 2 plus 1 gives us 3. But we multiply by that 6, which is the coefficient, and it gives us 18. All All right, so 18 atoms here plus the 18 atoms here means on our reactant side, we have a total of 36 atoms. That means for matter not to have been created or destroyed, on our product side, we can't have more than 36 atoms, and we can't have less than 36 atoms. We have to have exactly 36 atoms. So let's look at it. We have only subscripts here. Good. That means we don't have to do any multiplying since we don't have any coefficients. So 6 plus 12 is 18. 18 plus 6 gives us 24. So this section here, we have a total of 24. Over here, we still have to account for these. We do have a coefficient here, so we have to multiply times this subscript here. So 6 times 2 gives you 12. You add those two together. 24 plus 12 is 36. All right, so we have 36 atoms here, and we have 36 atoms here. So both sides, we have 36. Good. We didn't lose anything. We didn't gain anything on total atoms. Now we have to check each individual element because you have to have the same amount of each element on both sides to make sure that it is exactly the same. We can't have 24 carbon over here and only 10 carbon on the product side and say that it's balanced. I don't care if our totals for both ended up being 36 for both sides. You still have to have the exact same amount of each atom on each side. So we'll check that and see. First, we'll start with the carbon atoms. Your coefficient of 6 times 1 tells me there are 6 carbon atoms. So we'll write out 6 carbon atoms on our reactant side. Now we'll check the oxygens. Your coefficient of 6 times your subscript of 2 is 12 oxygens. All right, so we have 12 oxygens. Do we have any here? Yes, we do. That coefficient of 6 times this 1 for oxygen gives us 6. So 12 plus 6, 12 from here, and then the 6 from this part of your reactant side is 18. We have 18 total oxygens. And then our hydrogen, we have a coefficient of 6 times our subscript of 2, which gives us 12 total hydrogens. All right, we have to have that same thing on our product side as we had on our reactant side. We have to have the exact same thing. All right. So we list it out in the same order that we have over there. C equals, O equals, and H equals. We have to have the exact same elements. We have to have the exact same number of each element. And we have to have the exact same total of atoms on both sides for this to demonstrate the law of conservation of mass, or law of conservation of matter. All right. How many carbons do we have? Well, we have a total of 6 carbon. C6. So we can write that. Excellent. They match up. Boom. Boom. 6 on our reactant side, 6 on our product side. Let's see, oxygen. We have a total of 6 here. Plus, we have 6 times 2, 12 there. So we have 18 oxygen on our product side. Boom. 18. 18. They match up. Let's hope this last one matches up. Hydrogen. That one easy. We don't have to multiply by anything. So H12, we have 12 hydrogen and 12 hydrogen. So it checks out. This does demonstrate the law of conservation of mass, which states that matter can't be created or destroyed, only rearranged to form a different atom. We didn't lose any carbon atoms. We didn't lose any hydrogen atoms. We didn't lose any oxygen atoms. We didn't gain any. They stayed the same. All we did was rearrange them to turn your carbon dioxide and water into sugar and oxygen. That's all we did. If you have any questions, make sure you come up to see me. This has been your lesson on chemical equations with Coach Smith.